This video covers next generation firewalls, commonly abbreviated as NGFW. These firewalls add capabilities that stateful inspection doesn't have. The ability to look inside the packet content, identify applications by behavior rather than port number, and detect known attack patterns in real time. They're increasingly common at OT-IT boundaries in security mature industrial environments. A next-generation firewall combines stateful inspection with additional inspection engines that operate on packet payloads. Deep Packet Inspection, or DPI, means the firewall examines the content of packets, not just their headers. Instead of seeing TCP traffic on port 502, permit based on rule, it can read the actual payload and verify that what's on port 502 looks like a valid Modbus protocol. Application identification means the firewall identifies applications by analyzing their traffic behavior and content signatures, not just by port number. An application that runs on a non-standard port can still be identified correctly. An application that's trying to hide itself inside a permitted protocol can be detected. Intrusion prevention systems, or IPS functionality, means the NGFW compares traffic against a database of known attack signatures and behaviors. A recognized attack pattern, like a Modbus function code that's known to be used maliciously, will generate an alert or a block. Some NGFWs also support identity awareness, allowing rules to be written tied to specific user accounts and authenticated via Active Directory or similar, rather than just IP addresses. This is more relevant at IT, OT, DMZ boundaries than deep in the OT network. NGFWs are deployed at OT, IT boundaries and DMZ perimeters in more security mature OT architectures. Their value in OT comes primarily from two capabilities. First, industrial protocol awareness, as we said. Leading NGFWs, including Fortinet, FortiGate, Palo Alto Networks, and Cisco Firepower, ship with deep inspection profiles for common industrial protocols. Modbus, DNP3, Ethernet over IP, Profinet, OPC UA, and others. With these profiles active, the firewall isn't just permitting traffic on port 502 and assuming it's Modbus, it's actually parsing the Modbus frame, reading the function code, and applying rules based on what the application is doing. You can write rules like permit Modbus read coil commands from the SCADA server to PLC-A, but block all Modbus write commands from any source. That's a capability that stateful inspection alone can't provide. Second, anomaly and threat detection. The IPS engine detects known attack patterns targeting industrial protocols. The CISA National Cybersecurity and Communication Integration Center regularly publishes indicators of compromise and attack signatures for OT-targeted malware. Reputable NGFW vendors include these signatures in their IPS updates. Deep packet inspection and intrusion prevention work from databases of known patterns. Those databases are built primarily for IT protocol behavior, and industrial protocols have quirks that don't always match the pattern engine's expectations. An NGFW can misinterpret a legitimate OT transaction as an attack signature and block it. A specific Modbus function code that appears rarely in IT traffic might match a known attack pattern. A DNP3 message with an unusual flag combination might trigger a false positive. A block Modbus command during production is not a minor inconvenience. It means an operator command didn't reach the PLC or the SCADA server lost a polling response. Because of this, NGFW configuration in OT environments requires careful testing. The standard approach to deploy NGFW in detection-only mode initially, where you log alerts and don't block, where you collect logs over a period representing normal operations, and then you review the alerts for false positives and tune the inspection profiles to eliminate them, and then you can enable blocking. This validation process takes time, but it is essential. Work with your OT vendor on the protocol-specific inspection settings. If you're using Rockwell automation equipment with Ethernet IP, Rockwell's documentation describes valid function codes and parameter ranges. If you're using Siemens S7 PLCs, similar documentation exists for S7 COM. These documents are the reference for what valid traffic looks like, and they should inform how the NGFW inspection profiles are tuned. NGFWs provide the most value at boundaries where deep visibility into application behavior matters, specifically where you want to understand not just that traffic is flowing, but what it's doing. The OT-IT DMZ boundary is the primary placement. Traffic crossing from enterprise IT into the OT environment should receive the highest level of inspection available. An NGFW here provides both the access control of stateful inspection and the application visibility of deep packet inspection. The remote vendor access termination point is another high-value placement. A vendor connecting remotely should only be able to issue commands appropriate for their equipment and role. An NGFW that understands the industrial protocol can enforce that at the protocol level, not just at the port level. Deep within the OT network, between control VLANs and field device VLANs, a simpler stateful firewall may be sufficient and avoids the false positive risk. The more complex the inspection, the more careful the tuning required. In the next video, we'll cover how firewall rules are structured and the default deny principle, the most important configuration concept in OT firewall deployment. We'll see you there.